Hello, good morning. This is Teacher Annabelle, and welcome to Physics class. Well, we've been talking about energy since week 9. We talk about power, work, forms of energy, machines, and the role of energy for sustaining life. For you to understand better about energy, let us continue our lesson. Energy. In this kind of environment, just like in the picture on your screen right now, what do you think could be a source of energy here? How about here? Here and here? Well, the question seems to be so easy for you. When you are in the lower grades, you talk about the different sources of energy. In the first picture, you can see a waterfalls. The running water could be a source of energy. An environment near volcanoes can get energy from the heat under the surface of the earth. However, in those environments which is windy, they can get energy coming from the wind. And of course, from the last picture, those environment which seems to be very sunny or hot, they can get energy from the sun. We're about to start our lesson, but before we begin anything else, I would like you to prepare the following things with you. First, your physics book, a pen, and a copybook. Today's lesson is all about the sources of energy. Please open your book on page 161. Our main objectives for today is to identify the sources of energy and realize the impact of technology in energy innovation. Sources of energy. We have different sources of energy, like the energy that comes from the sun, which we know as solar energy. We have geothermal energy, which is the energy that comes from the heat underground. We also have nuclear energy, which is the energy that comes from the nuclear fusion or fission of some atoms. The sun is the source of practically all of our energy here on Earth. The energy from the burning wood comes from the sun. Even the energy we obtain from Earth's compost of the past, the fossil fuels, such as petroleum, coal, and natural gas. These fuels are created by photosynthesis, the process by which plants trap solar energy and store it as plant tissue. Solar power. Remember that sunlight is directly transformed into electricity by photovoltaic cells, like those we can find in solar-powered calculators or flexible solar shingles on the roof of some buildings. This is being used to generate electricity. However, we can also use the energy in sunlight indirectly. Example, sunlight evaporates water which later falls as rain. When rainwater flows into rivers, it turns water wheels. Wind and running water are both solar power. Wind is caused by uneven heating of Earth's surface, while running water is caused by evaporation, condensation, and precipitation at higher elevations. Both wind and power can be used to turn generator turbines within specially equipped machines. Look at the example on your screen right now. This is a house that uses solar shingles. Solar shingles look like a traditional asphalt shingles, but they are hooked into a home's electrical system to provide them electricity. Fuel cells. Look at the two pictures above. The first picture talks about electrolysis and the other one is what we call the fuel cells. Both of these processes has the presence of hydrogen. Hydrogen is so called as the least polluting of all fuels. One thing that you should know about hydrogen is that it takes energy to make this kind of element. Using electrolysis, we can extract hydrogen from water and other carbon compounds, but it can take energy. If you make the electrolysis process run backward, you have a fuel cell, the opposite reaction of electrolysis. If hydrogen and oxygen are recombined to form water, the process can be used to generate an electric current. So, in electrolysis, you're going to separate hydrogen from compounds and it takes up energy. However, in fuel cells, you're going to combine these atoms to make a compound, but it would be or it would generate an energy. Nuclear and geothermal energy. Both of this energy is not associated with solar energy. Remember that nuclear energy comes from the nuclear fusion and fission of atoms. However, geothermal energy comes from the energy underground. The most concentrated form of usable energy is stored in uranium and plutonium, which are nuclear fuels. Earth's interior is kept hot by producing a form of nuclear power, radioactivity, which has been used since the Earth was formed. A byproduct of radioactivity in Earth's interior is geothermal energy. Geothermal energy is held in underground reservoir of hot water. This energy is a practical energy source in areas of volcanic activity, such as in Iceland, New Zealand, Japan, and Hawaii. We have a lot of sources of energy thanks to our inventors, scientists, and engineers. As our technology grows fast, we can find more ways on how to obtain energy from our environment or surroundings. All right, time to know what did you learn from our lesson for today. Question number 1. What is the source of practically all of our energy on Earth? Very good. The sun. Can we say that a new source of energy is hydrogen? Well, the answer for that question is no. Hydrogen is not a new source of energy because it takes energy to extract hydrogen from water and carbon compounds. Remember, as the population increases, so does our needs for energy. That's why it's very important for us to realize how important it is to conserve energy. Here are some tips that you can do in order to conserve energy. Example, closing blinds and curtains to reduce heat in your home. You can also turn off any unused lights or electronics. You can do washing clothes in cold water or avoid taking showers between 3 p.m. and 7 p.m. That's our lesson for today. Thank you for listening. Don't forget to answer your task written in the weekly plan.